Quantum randomness. Is it truly random? Look at your hands, the lines on your palm. For millennia, people have believed those lines tell a story, a fate written in the flesh, a destiny predetermined by the gods, by the stars, by a cosmic script written at the dawn of time. Now, look up at the night sky. 1 trillion points of light, each a sun, each a possibility. We used to think that was the grand clockwork, a perfect, predictable machine. Planets moving in flawless orbits, a universe of cause and effect. If you knew the exact position and speed of every atom, you could, in theory, rewind the tape of reality, or fast forward it. Your birth, your life, this very moment, it was all just the inevitable unfolding of a chain reaction started at the Big Bang. A comforting thought, in a way, that everything has a purpose, a place, that nothing is truly accidental. But then, we looked deeper. We peered into the heart of an atom, and the solid, predictable world vanished. What we found there wasn't a tiny, solid ball. It was a ghost, a probability, a shimmering cloud of potential. And when we tried to measure it, to pin it down, it did something that shattered the classical world forever. It behaved randomly. Welcome, everyone. Today we are asking the single most profound question about the nature of reality: quantum randomness. Is it truly random? Let's start with the magic, the pure, unadulterated weirdness of the quantum realm. Imagine a single electron, not as a little planet, but as a ripple of possibility. It exists in a state of pure maybe. It is spinning both clockwise and counterclockwise at the same time. It is here and there and everywhere within its orbital cloud, a superposition of all possible states. It is only when we observe it, when we shine the light of our consciousness upon it, that this cloud of potential collapses. It chooses a state, a position, a spin. And here is the million-dollar question: how does it choose? According to the most widely accepted interpretation of quantum mechanics, the Copenhagen interpretation, it chooses at random, genuinely, utterly, irreducibly random. There is no hidden reason, no tiny, unseen gear turning. It is a cosmic coin toss, with odds we can calculate, but an outcome we can never, ever predict. The great Albert Einstein, a man who helped birth this revolution, hated this idea. He famously declared, "God does not play dice with the universe." He believed this randomness was just a placeholder, that underneath the quantum fuzz, there was a deeper, hidden reality, a set of hidden variables that determined the outcome. We just couldn't see them yet. To Einstein, the universe was still ultimately deterministic, still a clockwork, just a clockwork we hadn't fully taken apart. So, who was right? The revolutionary who gave us relativity, or the strange new science he helped create? For decades, it was a philosophical debate, a battle of worldviews. Then, in the 1960s, a physicist named John Bell devised a way to test it. Think of it not as a mathematical formula, but as a cosmic courtroom. Imagine we create two particles that are intimately linked, entangled. They are like two magical dice, created together and then flung to opposite ends of the galaxy. You roll one die here, and instantly, the other die, 1 billion light years away, shows the same number. In a deterministic Einsteinian world, this would be because these dice were loaded from the start. They had a secret instruction set, those hidden variables, programmed in at the moment of their creation. Their fate was sealed. But in a truly random quantum world, neither die has a number until it is observed. The act of looking at one here instantly forces the one 1 billion light years away to make its own random choice, a choice that just happens to match its partner. a connection faster than light, a spooky connection, as Einstein called it. The Bell test was the judge and jury, and the verdict, experiment after experiment with ever-increasing precision, has confirmed it. The universe is not locally real. There are no hidden variables. The dice are not loaded. The correlation between these entangled particles is stronger than any hidden, predetermined plan could ever account for. The universe, it seems, is playing dice. And Einstein was wrong. Let that sink in for a moment. At the very foundation of material existence, at the level that builds atoms and molecules, and eventually, you and me, there is a fundamental, inherent, and irreducible randomness. This isn't a failure of our knowledge. It is a feature of reality. Think of it as the cosmic canvas, the blank page upon which the story of the universe is written. Out of this primordial chaos, this quantum noise, this infinite potential, the solid world we know emerges. The chair you're sitting on is solid because of the statistical certainty of trillions upon trillions of these random events averaging out. But at its core, it is a dance of probabilities, a storm of chance. This is where the magic truly begins. This is where science starts to feel like the most potent mysticism. Because if the core of reality is random, what does that mean for us? This is the question that captivates the masses, the mystical implication. We feel in our souls that we have free will, that our choices matter, that the future is not written. But for centuries, science seemed to be against us. A deterministic universe, a chain of cause and effect, is a universe without true freedom. We are just complex biological machines playing out a program. But quantum randomness throws a wrench into those gears. It introduces an element of genuine, uncaused novelty into the cosmos. It means the universe is not just unfolding a pre-written script. It is writing the story, word by word, moment by moment. And at every single moment, at every single junction, the next word is chosen randomly. Now, does this prove free will? Not directly, but it opens the door. It creates the space for it. In a fully deterministic clockwork, there is no room for a truly free choice. It's an illusion. But in a universe with inherent randomness, the consciousness that arises from the complex network of our brain, itself a quantum system in many ways, could be the thing that harnesses this randomness. It could be the entity that biases the quantum dice. That turns pure chance into conscious choice. Your will, your you-ness, could be the non-physical force that guides the collapse of the probability waves inside your own mind. You are not a passenger in a predetermined train. You are the captain of a ship on a probabilistic sea, navigating through a fog of possibilities. And at every moment, your observation, your consciousness, is carving out a unique and genuine path forward. This leads us to the most mind-bending possibilities of all, the many worlds interpretation. What if every quantum random event doesn't just choose one outcome? What if it splits reality? Imagine that electrons spin. It can be up or down. In the Copenhagen view, it randomly picks one. But in the many worlds view, the universe literally splits in two. In one universe, you measure spin up and continue your life. In another, completely separate, equally real universe, a version of you measures spin down and continues on a different timeline. Every random quantum event, every flicker of every atom in every star, every decision made in the depths of your brain, triggers a new branching of the multiverse, an infinite number of parallel realities, constantly flowering into existence, a cosmic tree of life, where every possible outcome actually happens. In one universe, you are watching this video. In another, you never clicked on it. In one, you are a painter in Paris. In another, an astronaut on Mars. Every dream, every fear, every what if is playing out somewhere in the vast, holographic tapestry of the multiverse. The randomness we see, it's not randomness at all. It's just us, trapped on a single branch of an infinite tree, perceiving a single thread of a boundless tapestry. So, is it truly random? The answer is, it depends on where you're standing. From our limited, single universe perspective, yes, it is gloriously, magically random. It is the engine of novelty and freedom. But from a God's eye view, from outside the system, it might be a magnificent, deterministic unfolding of every single possibility all at once. So, where does this leave us? It leaves us in a universe far stranger, far more magical, and far more creative than we ever imagined. The solid ground of Newtonian physics is gone, replaced by a quantum sea of potential. We are not mere cogs in a machine. We are participants in a cosmic dance of creation. The ancient mystics spoke of the world as Maya, illusion. They spoke of a fundamental unity behind the veil of separation. Quantum mechanics, in its own precise, experimental language, is whispering the very same secret. The universe is not a collection of things, but a conversation of possibilities. And we, with our conscious minds, are part of that conversation. Our act of looking, of questioning, of being, is what solidifies the dream into reality. This journey, from the tiny atom to the vast multiverse, is the most important story we can ever tell. And if you want to dive even deeper, to explore how this quantum weirdness connects to consciousness, to destiny, and to the very real possibility that we live in a simulated holographic reality. I've written a book that explores all of this in thrilling detail. It's called Holographic Multiverse, and the link to get your copy is in the description below. In it, we connect these quantum dots to build a picture of reality that will forever change the way you see yourself and the cosmos. But for now, I want to hear from you. What do you think? Is this randomness the source of our freedom, or a beautiful chaos? Do you believe in a single universe of chance, or a multiverse of all possibilities? Let me know in the comments below. I read every single one. If this journey into the heart of reality sparked a sense of wonder in you, if it made you question the nature of your own existence, then please, do me a huge favor. Like this video, subscribe to the channel, and hit that notification bell. We are just getting started, and there are so many more mysteries to explore together. Thank you for watching. Remember, the universe is not just stranger than we imagine. It is stranger than we can imagine. Now go out there and collapse some wave functions.